Hi, this is Michael Armentrout, Wireless Products Manager at Silicon Labs. I'm going to show you a brief tutorial on the EZConfig setup module that's part of our Wireless Development Suite software. The WDS software is used for all our sub-gigahertz wireless devices and can be downloaded directly from our website. The EZConfig setup that I'll be showing you today is used specifically for our SI4355 and SI4455 EZ-Radio devices. Within this program, you'll be able to completely configure the device for your application needs and then load it directly onto the part for testing or automatically generate source code you'll use for your own program. Now, there are three methods you can use to set up the device configuration: a wizard to guide you through the setup, a table of preset configuration options, or a GUI that allows you to set up the device parameters yourself. And regardless of the method you use, you'll then be able to apply these settings to the demo code on the test board, directly control the test board for lab measurements, or generate configuration source code. So I'll walk you through a couple different scenarios to show you how each of these options work. Your first step, though, will be to make sure you have the latest version of WDS loaded from our website. If you plan to generate source code, you also want to make sure you have the IDE program from our website as well as a C compiler. So when you open WDS, it brings you to this screen. So the first thing I'm going to do is show you how to set up a basic output power measurement using our EZConfig table. So I'll first plug a demo board into the USB port, and the program automatically detects and identifies the board. So in this case, you see I'm using an SI4455 RF stick. So I'll select the radio configuration application. And now this screen shows the configuration options for the part. So the top third are the basic RF parameters of the device. The middle third is the EZConfig table, which is the possible configuration options. And then the bottom third are the output options for the configuration file. Now, since I'm using a 434 megahertz board, the first thing I'm going to do is change the center frequency to 434 megahertz. I can then provide the characteristics of the crystal on my board. So the crystal tolerance, this shows the ppm accuracy of the receive and the transmit oscillators in the system. And this is used to help best determine the frequency deviation and receiver bandwidth for the system. And so changing this selection is going to change the options listed below. I can then select my crystal center frequency and the crystal tuning. Now the crystal frequency tune adjusts the load capacitance on the oscillator, and that ensures you get an accurate frequency at the device. So if you click on the question mark, a graph is provided to help you adjust this value as needed for your specific crystal. But since we're using the Silicon Labs demo kits, I'm just going to leave this in its default setting for now. Now to the right, I can select my modulation source as either packet-based or direct. Now selecting the packet-based source enables the onboard packet handler features of the part, and this allows me to transmit and detect preamble, sync word, and CRC, whereas the direct mode simply transmits exactly the data that you send to the part from your microcontroller, and then also provides whatever data is received to the MCU on the receive side. And the next is the power level. This is a hex code that corresponds to a specific output power level of the device, but the exact output power for each code is going to vary somewhat depending on your antenna, the board layout, the matching you have. But a good guideline for what you can start with is shown if you click on the question mark here. This shows a graph with the hex value code that you can provide versus an estimated output power. And then lastly here is the channel spacing and the channel number. This is very useful if you're transmitting on multiple channels, but if you're only transmitting on one frequency, you can just select the channel number 0 and then it'll transmit at your center frequency. So the next step is to select an appropriate configuration. So we provide a table here that are the recommended configurations for the device. So all these configurations have been optimized and verified by Silicon Labs, and so they're really good options to choose. These provide recommended frequency deviation and receiver bandwidth for the various modulation rates, and then looking at FSK, GFSK, or OOK modulation. So I'm going to select a 5 kilobits per second data rate, FSK modulation, which for frequency deviation of 40 kilohertz and receiver bandwidth of 105 kilohertz. So the last thing I need to do is tell WDS what I want to do with this part. So the bottom panel shows the options available for, and each option then has a description explaining what that option does. Now, since I want to make a power measurement, I'm going to select the PN9, since that's going to configure the chip to transmit a pseudo-random code using the configuration options that I've selected up here. And then I'm going to select Lab Evaluation. And WDS calculates the configuration parameters that's needed and loads those onto the device. Now, when you're doing a lab evaluation, a new window comes up showing the parameters that you can change. So with your lab equipment connected, you can easily make adjustments to parameters such as your center frequency, your power level, and your crystal tuning. The next scenario I'll show you is how to set up two demo boards to communicate with each other using the configuration of your choice. For this example, I'll show you the configuration wizard. So to launch the wizard from this screen, just select Configuration Wizard button at the bottom of the main configuration panel, and that launches a new screen which will walk you through a series of questions about your application to help narrow down the best configuration for you to use. So you'll first select whether you want to use a packet handler or direct mode, and then you'll select the data rate and data throughput, and as always, if you have any questions about what's being asked, just select the question mark on the side. So next, you're going to select the regional standard where your product is going to be used. So this is to make sure that any recommended configuration options will comply with these standards. And then you're going to select the frequency band and crystal tolerance. And then from your inputs, the wizard's going to provide recommended transmitter settings depending on the type of antenna you're using. So in this case, it's providing two options. One for a PCB bifa antenna and the other for a PCB monopole antenna. And it also provides an estimate of the range you'll be able to achieve with these settings. So lastly, then, it's providing the recommended RF settings. So once you've selected your desired settings, just click Done, and it brings you back to the radio control panel, which has been updated to match the recommended settings for your application. So from here, you're still free to change any parameter you'd like and select any output option. But for now, we're going to accept the recommended settings from the wizard and then load these settings onto the demo board as customized demo code. So for this, I'm going to select a packet TX so that the board that I have connected will act as a transmitter for the test link, and then select Load Firmware. And again, this goes through and it calculates the parameters and loads them onto the board. So now that that's done, I'm going to disconnect my first board and connect up my second board. And I have the power switch on these boards set to battery so that the WDS maintains all the same settings. If I select this to the USB power option, then WDS will actually reset and allow you to start from scratch. So on the second demo board, I'm going to select Packet RX, and so that's going to be the receiver, and hit Load Firmware again. And it loads everything on. And now I have completed the link. I have now a one-way link between the two demo boards at the configuration I've chosen. Now for the last example, I've disconnected the demo boards because now I want to show you how to create source code for your desired configuration. Now when I disconnect the boards, WDS brings me back to this screen. So I'll select Simulation Mode since I won't be working directly with any hardware this time. But since there's no hardware attached, I'll need to let WDS know what product I want to configure. So I'll select Radio Configuration Application and then SI4455. And then this brings me back to the configuration panel. Now, let's assume this time that the configuration that you want is not listed in the table of recommended settings. So for example, let's say you want FSK at 5 kilobits per second, but you want to use a 90 kilohertz frequency deviation. Now since that option does not exist in the table, you'll need to create this as a new entry. So simply click Add Config, and then select the options you want in this panel. So I'll select 90 kilohertz frequency deviation, 5 kilobits per second. And now I have the option to select either the exact crystal oscillator tolerances that I'm using or a specific bandwidth that I want. Now, selecting the crystal tolerance is nice since the program will then provide you with the recommended receiver bandwidth optimized for your specified tolerance and frequency deviation. However, if you know the exact receiver bandwidth, then you can always just directly put it in here. However, in this case, I want to know for 90 kilohertz, what is the optimal receiver bandwidth that I should be using? So I'll put in 30 ppm, which is the crystal I'm using, click Add, and now the program is going to calculate all of the internal register settings that's needed for this new configuration. Now once that's complete, the new configuration shows up on the EZConfig table of options. Now, since we selected packet-based modulation source, you're also able to change the packet handler features using the Advanced Packet Handler tab. So here you can select the preamble length, preamble detection threshold, your sync word length, sync word that you're using. You can enable CRC for error detection. You can also enable Manchester mode coding for your data. You also have the option to select fixed packet length for all data packets or a variable packet length. If you select the variable packet length, then the first byte of all the data that's transmitted will be the packet length. Then you can also use additional tabs to enable interrupts, configure your GPIOs. But once you have all the configurations set up exactly how you want it, you can generate the source code by selecting the option for the code you want to generate. So in this case, I'll select empty framework, since that option will give me just the code that I need to start my program, and then launch IDE. Now this launches a new window where you can select the MCU that you'll use, the C compiler, and the path for all the files that will be used. So I'll be using the F930 MCU, but I want to select the SDCC compiler. And so everything else looks correct, so I'm going to hit OK. And then this launches the IDE with all of the configuration code that's needed, ready for me to use, start coding up my program around that. Now, another option that you may want to use is to start with your own, to start with the demo code that's provided and use that as the basis for your own program. So to do that, all you need to do is select the demo code that you want, hit the launch IDE again, and then you can use that demo code as the basis for your own program. So I hope this answers any questions that you have on the EZRadio EZConfig setup in our WDS software. But please visit our website to download this program, get additional information, user guides on all of our EZRadio and other wireless products. Thank you. Have a great day.